Let's look at a new type of function, one where the exponent is actually the variable, as you see right there. Y equals 2 to the x power. So I've got a t-chart already built, and we are going to replace our x with each one of those numbers and see what it equals, and then we will graph it. So if I replace the x with 3, that means I'm going to have 2 to the third power. So I'm replacing the x with the 3. So that's 2 to the third power, which is 8. 2 to the second power, replacing the x with a 2, gives me 2 to the second power, and 2 times 2 is 4. 2 to the first power, that's just 2. 2 to the 0 power. Do you remember what a 0 power means? Well, anything to the 0 power equals 1. So 2 to the 0 power, or anything to the 0 power, is going to equal 1. Then we get our negative exponents. So 2 to the negative 1 power. What did negative exponents mean? Recall that negative exponents are the reciprocal exponents. So we take the 2 and we place it underneath a 1 in the bottom of a fraction. So it becomes 1 over 2 to the positive first power, and that is 1/2. So 2 to the negative 2 power would equal 1 over 2 to the positive 2 power, and that would be 1 over 4, because 2 to the second power in the denominator is 4, and then we have the 1 on the top, so 1 over 4. And then finally, 2 to the negative third power would equal 1 over 2 to the positive third power, and 2 times 2 times 2 would be 8, so that's 1 over 8. So let's graph those. So 3, 8 is to the right 3 and up 8, so right there. 2, 4, right there. Whoop. Actually, more right there. 2, 1. Excuse me, 1, 2, so over 1, up 2. And then 0, 1, so not left or right any, but just up 1. And then negative 1, 1/2, so I'm going up only half of a unit. Negative 2, 1/4, so over 2, but up 1/4, so that's just barely above the x-axis. And then negative 3, 1/8, so over 3 and up 1/8 of a unit, that's actually a little bit less than 1/4 above the x-axis, so about right there. So then as I graph it, you can see how very steep it is over on the right side. But on the left side, it is flattening out. So roughly about like that. So you can see what is going on the right side, but what's happening on the left side? I mean, how flat does it get? And exactly when does it touch the x-axis? So here is y equals 2 to the x power. So again, you can see how it's increasing very rapidly on the right side. But my question was, what's going on the left side of the graph? When does it touch the x-axis? So it looks like it touches the x-axis around that negative 6. But when I zoom into it, you can see actually it does not. It does not touch the x-axis at negative 6. It's a little bit higher than negative 6, than the axis on negative 6. So let's keep going to the left. And notice it is getting closer and closer and closer. And it finally looks like it touches the x-axis about probably around negative 10 or so. But again, once I zoom in closer, you can see it actually does not touch at negative 10. It's still higher than the x-axis at negative 10. But the further I get to the left, it does continue to get closer and 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 closer. And just when you think it hits the x-axis, it's like I need to go a little more ways, but it is getting closer. There we go. We're finally going to hit it. Looks like around negative 13. Finally hit the x-axis at negative 13. There it is, negative 13. But as soon as I zoom in, you can see it actually does not. It is still above the x-axis at negative 13. So why is that? Why is it never touching the x-axis? And the reason it's never touching the x-axis is because it is impossible for this equation to ever have a y value equal to 0. No matter what you plug in for x, you will always get some number that is not going to be a 0. When we plug in a positive number like 321, you can see that it was much higher over here, much higher than the x-axis. When we plugged in 0, even when you plugged in 0, you still got a positive number because anything to the 0 power still equals positive 1. And even if we plugged in negative numbers, we still got positive answers because negative numbers are just the reciprocal exponents. We just take those numbers and put them to the bottom of a fraction. So it's never going to hit the x-axis unless there's some sort of shift, which we will talk about in this section as well. This type of function, like y equals 100 to the x power, where the base is a constant and the exponent is the independent variable, in other words, the exponent is the x, is an exponential function. An exponential growth function is a function in the form of f of x or y equals b to the x power, where b is greater than 1. The graph of an exponential function has an asymptote, which a line is the graph approaches. So that x-axis is referred to as an asymptote. Very important definition right there, asymptote. It is a line that the graph approaches, but it never reaches. So you saw on the Desmos graph that I showed you that it kept getting closer and closer to the x-axis, but it never actually touched it. Let's do another one. This one says graph y equals 3 to the x power, and we're going to state the domain and range. So to see what y equals 3 to the x power looks like, we are going to do another t-chart. So we're going to take each one of the numbers, place them in for x. So we get 3, and we replace the x with this third power right here, 3 to the third power. 3 to the third power is 27. So the first point I would graph is going to be 327. So you're going to see that's going to be pretty high off my typical graphs. 3 to the second power, so that's 3 times 3, which is 9. 3 to the first power is just 3. 3 to the 0 power, so what's anything to the 0 power? Well, that's going to be 1. And then we get to our negative exponents. So 3 to the negative 1 power is going to be the same as 1 over 3 to the positive 1 power, which is 1/3. 3 to the negative 2 power is going to be 1 over 3 to the second power, and that is 1/9. And 3 to the negative third power, that's going to equal 1 over 3 to the positive third power. And we already know 3 to the third power is 27 from the very first point that I plugged in. So this will be 1 over 27. So when I graph those, 327, so over 3 and up 27 is going to go way off my graph and way off the screen. So I'm not going to bother to graph that one. Running out of room. 2, 9, we can graph that one. So 2, 9 is right there. 1, 3, so over 1, up 3. 0, 1. Negative 1, 1/3, so it's not quite halfway up, so 1/3. Negative 2, 1/9. And negative 3, 1/27. So I'll try to get it just barely above the x-axis. So remember, it's not supposed to touch the x-axis, so you got to be very careful as you draw this. Looks almost parallel to the naked eye to the x-axis. Try not to touch it, though. Definitely don't cross it. And then suddenly, zoom, it zooms up like a rocket ship. Almost straight up. Not quite straight up, but almost straight up. And then there's your graph. So the second part of that is state the domain and the range. So what's the domain of an exponential function? So notice that there was every type of number we could plug in. We plugged in positive numbers. Right here, we plugged in those positive numbers. We could plug in 0. We could plug in negative numbers. Right here, we had negative numbers. We could plug those in. We can actually plug in fractions too, even though we didn't. You can see on the graph that fractions do work. So because there is like 1 is very close to 2. Whoops, I accidentally erased it. It's right in there. It's actually about 1 or 1/2, 1.7, about right there. We haven't talked about fractional exponents yet, but we will. So since there's every type of number we can plug in for x, and that it does continue all the way to the left forever, and it is moving to the right slightly because this part of the graph is not perfectly straight up. So that means that the domain is all real numbers. The range of this graph, so notice it does continue to go upward very, very, very rapidly. So it keeps going up forever and ever and ever. But notice it never does touch the x-axis, and since it never touches the x-axis, that means it will never reach 0. So the range is going to be y is greater than 0, and that is not greater than or equal to. If it equal to 0, it means it would touch the x-axis somewhere, because on the x-axis is where the y value equals 0. But since it can't touch the x-axis, we would say it is y is greater than 0. So you can see on Desmos, the green graph is 3 to the x power, and you can see how it actually increases much rapidly. It's much more steeper than the 2 to the x power. But when you look over on the left side of the graph, it actually is much flatter once it gets past into quadrant 2.